Today we're talking a little bit about interaction models continued, and then we'll discuss moderation and mediation. I know some of you are very excited for this. I'm excited too. There's one of my children. Hi. Okay, interactions review. So just a reminder here that the question of interactions that they ask is, does the relation of x1 with y change across levels of x2? And another way to think about that is whether the relation of x1 with y is dependent on or depends on x2. And last we have, does x2 moderate the relation of x1 with y? And all three of those are just three different ways to ask the same question. And the statistical significance of that interaction term answers this question. So the extent to which the interaction term is significant tells you whether x2 is moderating the relationship of x1 with y. If it's not significant, it means it's not moderating it. And if it is significant, that means it is moderating it. And so a couple of people who I talked with this week in office hours or in emails asked, why does the size and significance of the main effect change when the interaction is included in the model? If you remember, we did a couple of examples last time where we had a main effect and then I put an interaction in the model and it changes what those significant tests look like. And it changes because once you have the main effect in the once you have the interaction in the model, you can now only interpret those main effects at that exact location on the other x. Remember how I talked about originally you could say controlling for x1, here's the relation of x2 with y. And now you have to say when x1 is 0, this is the relation of x2 with y. So it's that specificity of locating it in space. And I'll show you why that is. With our CATS data. Okay, so what I've done first is I've gone back to our CATS data and I'm looking at predicting how playful a cat is. Excuse me 1 second. Okay, so we're predicting how playful a cat is from how curious the cat is and whether the cat lives in New Zealand, remember that's what this NZ stands for, or lives in Australia. We did this before. We've looked at these relationships before, so I pulled this from one of our in-class projects. So here, the way that you interpret this should be pretty familiar to you because we've done these multiple regressions for quite a while now. And so in this one, you can say holding x2 constant, which in this case is New Zealand. When I'm holding country constant, the more curious a cat is, the higher their playfulness rating is. And the other thing that we see, which I think is really interesting, is that if you're holding curiosity constant, people in New Zealand are rating their cats as significantly more playful than people who are in Australia. I don't know what that means. Do we think that Australian cats are less playful, or people in Australia use the word playful differently than people in New Zealand? Maybe a little of both. Doubtful that cats in one country are actually more playful. I doubt it. I would really like to see the supposed causal mechanism behind that. Haha. Sorry, Nina, can I explain which one more time? Sorry, Nina, I'm going to call you out.
No, yeah, no, that's fine. Sorry, I'm just turning my camera on okay. So I can speak instead of typing. But sorry, can you just explain one more time I don't know, kind of the whole thing? I think I'm still just having a little bit of trouble. I'm just having a little bit of trouble, full stop.
Absolutely. So right now we're in multiple regression land. So we remember multiple regression land is week 3. We're not in interactions yet. So all
Okay.
we're doing right now is interpreting our regular old multiple regression. So all these lines are straight. We're not even testing whether they're not straight, whether they're not parallel. We're just looking at overall, is curiosity, holding New Zealand constant, is curiosity related to our outcome, which is playfulness, and holding curiosity constant is New Zealand related to our outcome. So that's where we are right now. Now, as we move on, next, what I'm going to do next is I'm going to walk through plugging in some values into this regression equation. And then I'm going to introduce an interaction and we'll do a parallel. So we're still staying there. And then I have two questions related to being primary predictors. And so the answer is no. You don't have to have a primary predictor. You also don't have to, there's no mathematical distinction between which variable is a moderator or not. But we're not talking about moderators yet. So hold on to those moderator-based questions because we'll get to that in about 2 slides. So here, this is still the same multiple regression equation. I just have 2 predictors. One's dichotomous and one's continuous. Here is, I've harvested those pieces out of the equation. And I sort of color-coded them here for you. So 269, that's our constant. That's our y-intercept. And then I have 0.45 times x1, which is curiosity. And then I have 0.33-ish times x2, which is New Zealand. And so now, one of the things we can do is you can pick a probable value for x1. That's not new. We've done that before. What's different is that before I've had you pick values for x1 and x2. Right now, I'm only going to ask you to pick values for one of these predictors. So low curiosity, for example, is a score of 1 on the curiosity scale. So if here we have someone who is, if this cat was rated as a 1 on curiosity, they're very low on curiosity, then I can reduce this equation. I don't have a value for x2 yet, but I have a value for x1. So I can combine all of this together, because these are all just numbers, to get me y is equal to 3.14, and then this term is still here. This is how related x2 is with y. Now I could pick another value of x1 and plug it in. Here I've done high curiosity, which is 4. You see all I've done here is change out what the xy value is. So this is for a very curious cat. A very curious cat, my y is going to be equal to 4.49 plus 0.33 times x2. So 0.33 will be multiplied by x2 no matter what. No matter what I plug in for x1. I'm always going to multiply whatever my value is here for x2. I miss seeing all your faces so that I could see if this is completely making sense or completely lost. You're probably saying, why are you doing this? I know how to solve for x. I know how to solve for y. Why do I care about this? And you care about this because of what we're going to do next, which is we're going to introduce interactions. My point here is that this 0.33 is always 0.33. It does not matter what happens. And if I did the opposite, the same is true. If I plugged in an expected value for x2, this value is always going to be 0.45 times x1, no matter what. So, next, I have now added an interaction. Now this interaction here I wrote as x. I'm sorry, that was shorthand as I was coding quickly before class. And so this x is the interaction between curiosity and New Zealand. And so the question here is, does country moderate the relation between curiosity and playfulness? Now, to the question that someone asked earlier, which is, do you always need to have a target or focal variable? The answer is no, that there's no distinction conceptually between New Zealand being the moderator here or curiosity being the moderator here? Yes, either one of them can serve as the moderator. Mathematically, they're identical. It's up to you. Remember, back to our ethics week, it's back to you as the person with control and understanding of these data to know what that means and to know how to interpret it and what makes the most sense for your story. So in this case, we can look at these interpretations. So instead of saying, oh, look at this, I didn't change these. Instead of saying holding x2 constant, which we can't say anymore, that is from my last one I just copied over and didn't change. So instead of holding x2 constant, remember, once the interaction is in the model, I have to locate it in space. So I have to say, for cats from New Zealand, nope, from Australia, because those are the cats for when New Zealand is 0. When New Zealand is 0, then we can say the relation, having a hard time typing here, between curiosity and playfulness is significantly different from 0. 0.49. So I'm pulling that number from here. And do you see why before it was not okay? Because I was saying holding it constant. And now I have to switch it to say just at this place. And the same here. I can only say when curiosity is 0. People in New Zealand are rating their cats as more playful than those from Australia. And here I'm saying B equals 0.860, and my p-value is less than 0.001. So again, it's significantly different from 0. Now the other piece here is the interpretation of the interaction. And for the interaction, it's telling me that this is moderating the relationship between curiosity and playfulness. So yes, I have a significant moderation model here. My moderation is significant. And so as I move from here, okay, now. Oh, gosh darn it, push the wrong button again. Shantanu says, is that because it's negative? No, but it is because it is significantly different from 0. So moderation just means that the relationship of curiosity with playfulness depends on whether we're talking about cats from Australia or cats from New Zealand. What does it mean to depend on that? That's a little bit confusing. That's what I want to get into with our math next. So this could be positive or negative, it wouldn't matter. Do you only need the p-value of the b-weight of the interaction variable? You do need all of the above, but everyone seems to understand the r-squared values and everyone seems to understand the f values that we've been talking about previously. But these are the places where I feel like everyone's still a little bit confused. So as we move on, all we need to know in order to understand whether moderation is significant or whether the interaction is significant is this interaction variable. All right, so I'm going to do the same thing we did before. I have harvested all of these numbers and I've put them into this equation. Remember how we have the intercept plus 0.49 times whatever we plug in for x1 plus 0.86 times whatever we plug in for x2, and then minus 0.10 And then remember, because it's the interaction variable, we have to say times x1 times x2.
Dr. Logan, can I ask a quick question?
Yeah, sure, Jamie.
About so the x1 times x2, I think I just have a clarifying question about moderation. So do we always have to multiply the two predictors together, or can we have a completely separate variable that modifies the relationship between the two predictors?
So anytime you have an interaction in your model, the interaction is by definition a multiplication of the two variables together. And so anytime that interaction is in the model, you have to also include the two variables that comprise it into the model. So you can have as many predictors as you want in this model, as long as the two variables that comprise this interaction are also in the model. I'm not sure I answered that. Let me say it again. If I have a third variable in this model, say whether the cat is male, I could have, is the cat male? And then, is the cat curious? And is the cat from New Zealand? The interaction term is still asking about the moderation of curiosity and New Zealand. So it's still only asking about those two variables that are it's still only talking about the moderation of curiosity by New Zealand and New Zealand by curiosity.
Okay, so you can't just like throw something else in there. They have to be predictors that you're already looking at in the model.
Yes, because here's the reason. If you put just an interaction term in your model, then none of the math works. It's another instance of the statistics don't know where they come from. And so if you just put in the interaction term into the model, the analysis just thinks it's some variable with the range that it has. It doesn't know that it has unique properties that are based on other variables. So you're only testing a moderation effect if you include both x1, x2, and the interaction of x1 with x2.
Okay, can I ask one more question? And we can talk offline if I'm taking too much time. So x1 and x2, they start as two different things. You combine them into the same thing, the interaction. So the interaction, are both variables then moderating each other in relation to the outcome then?
Yes.
Okay. Thank you. I appreciate it.
Yes, good. I'm glad you asked. That's exactly right. And I like the way you phrase that, because I've said it the opposite, which is one can moderate the other. It doesn't matter which one's the moderator, but they are both moderating one another simultaneously. You can talk about it in any way that makes sense for your story. But yes, they're both moderating each other.
Thank you so much.
Yeah. Is that Nina?
Yeah, sorry. Yeah. So if you're using this to do your interaction, like this format where you're going to do each independent variable and then the interaction variable, can you introduce another thing into the model, or should you only ever be using the two that create your interaction variable? Like, could you do curiosity New Zealand, the interaction of curiosity in New Zealand, and then also like the sex of the cat?
Yes, you can do exactly that. Excellent. So you can have as many predictors as you want. And just to like really freak you out, you can have as many interactions as you want. So if you have 8 variables, you can have 8 variables and then the interaction of every variable with every other variable in the model. As long as any variable that you want to look at moderation for, or any variable you want to look at an interaction with, as long as you have all of the, I guess you could call it first level predictors. So x1, x2, and then x1, 2. So as long as you have both x1 and x2 in the model, then when you put the interaction between the two of them in, the multiplication term, it is indicating the interaction. It's allowing the relationship of x1 with y to change across x2.
Okay, thank you.
Okay, can I ask a follow-up?
Yeah, hi, Michelle.
Sorry. So if you have multiple variables in that aren't part of the interaction, when you're working with the equation, do you just keep adding, so whatever the value is, so say you had the gender as 1, so it's not part of the interaction, but when you're actually doing the calculation in Excel to make the line, do you just add in, keep that in as a constant basically? So it's you know, whatever the point, sorry, I can't have words here. Whatever your B value would be times whatever the, say, average was that you calculated from the descriptive variables?
Yes, that's exactly how I would suggest you do it. If it's not a focal variable, but something you just want to have controlled for in your model, for example, sometimes there are variables like that. Like, I'm not actually interested if boys and girls or male and female cats are different on this variable, but I know that they might be, and I just want to get it out of the way. Sometimes you might have a variable like that. But yes, what you can absolutely do it exactly like that. Just keep that 1 at 0 and leave it in your model. So you're always calculating out to get your estimated y each time. As many variables as you want. In fact, if you were an economist, if you guys were in, if I was an economics professor, we'd probably have 30 variables already, because they just really like putting variables in their models. Yeah, I like it simpler. Okay, so let's talk about why x1 and its relationship with y is dependent on x2. What does that mean? Now, what we're going to do is, just like we did before, we're going to fill in probable values of x1. So remember, low curiosity is 1. So now I'm going to plug in 1 for every instance of x1. And look here, I have to put it in twice. 0.49 times 1. And right here, I have to plug it in as well. Okay, and now I can reduce this equation. I can combine this together, and I can combine this together, because these are both x2s. So now the reduction of this is 2.97 plus 0.76 times x2. And so this right here is the relationship of x2 with y when x1 equals 1. This up here, remember, is the relationship of x2 with y when curiosity is 0. If curiosity is 0, then my expected difference between New Zealand cats and Australian cats is 0.86. But through this reduction, I see that the relationship between, or the difference between Australian cats and New Zealand cats, when curiosity is 1, that difference is only 0.76. So the relationship, or the difference between New Zealand cats and Australian cats, depends on the value of curiosity. I'm going to do one more. So we're going to fill in a probable value again. This is the same as it was before. Now I have high curiosity, which is 4. I plug in 4 at both places where x1 is supposed to go. And then I'm going to reduce this equation. This is 0.49 times 4. I did all this math on my calculator, and I did it twice because I am very bad at math. That is my 9-year-old laughing at me for being very bad at math. He's better than me, he says. All right, so we can reduce this equation again. 2.48 plus 0.49 times 4. And this can also be combined. And the final product here is 3.46 plus 0.46 times x2. So our intercept is now different. This is the place where it's going to cross the y-axis. And our relationship of x2 with y is now different. Look at how different it is. All the way up here, when my x2 is 4, or my x1 is 4, all of a sudden x2 is now 0.46. Where we started, when curiosity was 0, the difference was 0.86. So that gap depends on where we're putting x1. I wanted to do it one more time just to show you that it's not a fluke about cats and Australia. This is the what we used last week when we were doing at the end of class. We had this little quiz talking about interpreting these interaction effects. So this is party line, which is low is more Republican and high was more Democrat. And then this was education level, where low was less education and high was more education. And this is the interaction between the two. And we're looking at the number of topics they get about the news online. And so here I've harvested all of these things from the equation, 0.46, 0.19, 0.06. That's the interaction, so I have to have x1 and x2. Now I'm going to fill in a probable value for one of my x's. This is low education is 1. So if I fill in 1 here and 1 here, I can reduce it down, and I get, just like we did before, I can get this value here, which is 0.25 times x2. So when 0.25 here is the relationship of x2 with y, when x1, education, is 1. Now when education was 0, what was the relationship of party line with y? When x2 was 0. Did I do this education? That is party line, which I think I've 0.46 times 1. So I did it backwards. So x2 here is education. So what's the relationship of education? Whoops. 1 is, so 1 here for x1 was party line, so that was more Republican. Come on. So here I have 1 is more Republican. I'm filling that in because party line times 0.46 gives me that. So now, I apologize, that was a little bit confusing. When party line was 0, the relationship of education with our outcome was 0.19. Now that I've moved up, the relationship is 0.25. That slope is steeper. And I can do it again. But I didn't do it again. Okay, well, you can do it again. You can plug in multiple values and see how that relationship changes across the different values of your x. Okay, now, the reason why I walked through this in such detail is because this is what I want you to do now with your homeworks. So, if you will pull back up the interaction homework that you turned in for homework 7, part of that assignment was to write the regression equation, so you should have that already. I want you to pick a probable value for just one of your x variables. That can be 1, it can be 10, whatever is a probable value for one of your x variables. And reduce the equation to answer what the relation is of the other x with y. And I'm going to give you 5 minutes to do that right now. Which is easier? Can I get a like, 1 is this example screen where I have mathed it out for you, and 2 is this thing where I give you the steps. Which would you rather see? So far unanimous, but I only have 3 votes. Okay, so what I'll do is I'll leave this up for the first minute and then I'll switch back to the other one. There we go. I compromised for you. Okay, that is time up. So what I'm going to do now is put you into groups for another about, I want you back here by 5, so I'll put you in groups for about 5-6 minutes in order for you to discuss what you just tried to do, and whatever equation you used and tried it out on is fine. So this is exactly as Christy pointed out. She just noticed that her equation was not quite right, and that's fine. This is exactly what I want to catch. I want you to be able to catch how these equations are working and what's happening with them. So I'm setting another timer, and I'm going to send you into rooms for a couple of minutes to discuss your answers, and then I will come visit you. Okay. Okay, I am here alone, so I'm going to go visit someone.
User satisfaction. Hi.
Hi, randomly selected breakout room.
Hello.
My Y is user satisfaction, and it's equal to 9.650 plus 0.002 by X1, which is the electronical word of mouth that people read, or before buying the product, they go through the online reviews and read about it or not. And minus 0.1 by X2, which is gender. And here female are 0, male are 1. Plus my interaction is 0.017 by E1, X1 by X2.
See if you can share your, I mean, if you want to share your screen, I think you
sure.
should be able to.
Sure.
I could be absolutely wrong about that. Sometimes it works and sometimes it doesn't. Oh, great.
Yeah.
Good.
It's here.
Cool. So you tried out your equation?
Yeah.
Does your X2 change when you've plugged in an X1 or vice versa?
You mean for picking a number?
Mm-hmm.
Yeah, I picked gender as a female, so X2 will be 0, and my equation is Y equal to 9.650 plus 0.002 by X1.
So I don't see that here. Do you have that somewhere else?
Oh, I just write it down on
okay,
paper.
gotcha.
Yeah, but I think I have the equation here.
No, that's fine. I was just making sure I wasn't missing it.
Here is the equation.
Uh-huh.
And because I put for the gender 0, so we don't have these 2 parts, and we just have these first 3 parameters.
Okay, so when gender is 0, then the relationship here, or the associating EWOM, is that the reading the reviews first?
Yeah.
So that's
electronical word of mouth. Yeah.
Oh, word of mouth. So that relationship is 0.02.
Yeah,
and
exactly.
So on your paper then, when you plugged in a value of 1 for gender, what does that change this? What is the coefficient that associates EWOM-C with Y?
Oh, I didn't do that because I was just explaining to Patrick that I made Shantana's mistake as well. I was going through the party line.
Oh, okay, gotcha.
Yeah.
I should have left that part on here, on that slide. Okay, so but you can do that. Yeah, Patrick, you want to try yours?
Yeah, sure.
Sorry, yeah, can I share mine just so I can make sure I understand? Because I wrote it out.
Yeah, sure. I stopped sharing.
Okay. So can you see, this is where I was doing the work just
Yep.
now.
I can.
So for my X1 on the first time around, I plugged in a 1 here and I left everything else the same. I plugged in the 1 over here as well.
Uh-huh.
And then I combined the like terms and reduced it. And this was the new equation. So then what you're asking essentially is this number, like what the new X2 is that right?
Yes.
Okay. And then I changed it to 10 the second time around, and it changed it to a positive 0.195.
Interesting. So when it's 0, it's also positive. Is that right? I've got to zoom it in a little bit.
If I go up, you mean?
No, right here. So when I'm looking at
Oh.
the first regression equation, if you plug in oh, you're plugging in x1. Okay, gotcha.
Yeah.
So when x1 is 0, x2 is negative 0.115.
Yeah.
Yes.
Gotcha. And so then as you changed it to 1, now it's still negative. It's negative 0.084. And once you get to 10, now that relationship is positive 0.195.
Yes. Yeah.
Yeah, cool. Does that make sense?
Yep, that does. But I might have done my graph wrong. Does that look weird because they look really parallel, or is it just because it's...
They do look really parallel. Let's see. It looks like they are not very far apart. It looks like they're far apart by like 1 point or so.
Yeah,
Which
I might have done that wrong because the interaction is significant, but I don't know.
Interaction is significant. Is ACE's total is 15. Oh no, our time is up. Ugh.
Oh, sorry.
Well, that was actually I set that timer so we'd have 1 minute left. So, but that's exactly what I wanted to make sure that you had. So yes, it
Okay.
could be that the graph is not right, but it also could be that they are just that interaction is so subtle that you can't see it at this range.
Okay.
Wow.
Okay, that makes sense.
Cool. Okay, so that does change. Fun.
All right. Thank you.
Yeah. Okay. I'll see you later.
See you.
Mediation, and suddenly it's like, what the heck? Hello.
Uh-oh. I don't like hearing what the heck. As soon as I do a break.
No, I think there was finally a breakthrough here. So we were trying to interpret what the math actually means instead of just being like, okay, well, this is the relationship.
Okay.
So is it correct in saying that, like, if you're picturing the graph,
Okay.
and we've picked our x value, like that's the whole point, is so we've picked one x value.
Yes.
And you have this other variable up here that can be whatever we want.
Mm-hmm.
And so like instead of saying when x1 is 0, we're saying when x1 is 50.
Okay.
This other variable is related to your outcome. Like a 1 point increase in this variable is associated with this increase or decrease in your outcome.
Yes.
Okay.
You got it. We've been always graphing it when it's 0, and now we're saying we can graph it at any point. We can graph it not just at 0 and 1.
And that was the point of playing with the lines, because those lines are not just shifting, they're changing at completely different points. So it's reflecting just different lines, but the colors stayed the same, and it confused me.
Yeah.
So it's not that the lines are just changing, it's that they're whole different lines because you're picking different points for your moderating variable.
Yeah. That was amazing. Well done.
Yay!
Okay, unfortunately our time is up. I got to go back.
Okay.
Okay, bye. Well, hello. I was trying to leave the breakout rooms. I'm not sure how